Direct metal laser sintering, also known as DMLS, is an additive manufacturing technology that creates metal parts directly from 3D CAD data without the need for tooling. DMLS utilizes a variety of metal and alloy materials, such as stainless steel, cobalt chrome, and Inconel, to create strong, durable parts and prototypes. DMLS is an excellent choice for functional metal prototypes, high-temperature applications, and end-use parts. The DMLS process begins in the same fashion as other layer additive manufacturing technologies. A program takes 3D CAD data and mathematically slices it into 2D cross-sections. Each of these sections will act as a blueprint, telling the DMLS machine exactly where to sinter the metal material. The data is then transferred to the DMLS equipment. A recoater assembly pushes powdered metal material from the powder supply to create a uniform layer over the base plate. A laser then draws a 2D cross-section on the surface of the build material, heating and fusing the material. Once a single layer is complete, the base plate is lowered just enough to make room for the next layer. More material is raised from the cartridge and recoated evenly upon the previously sintered layer. The DMLS machine continues to sinter layer upon layer, building from the bottom up. As the part is built, support structures are added to give supplemental strength to fine features and overhanging surfaces. The completed part is then removed from the base plate and treated with an age-hardening heat process to further harden the part. Any support structures are also removed at this time. With numerous surface treatment and hand polishing options available through service providers, DMLS parts can be used in highly cosmetic applications. Typical uses for DMLS include tools and manufacturing aids, small integrated structures, dental components, surgical implants, and aerospace parts.
A few years ago, someone had told me that this intake manifold is 3D printed. I don't know if I'd believe them. It really looks like a casted piece. The guys that made it were nice enough to let us film the whole process, and I'm going to share that with you guys now. Let's check it out. The place that did the printing for us is called Mnemotechnic in Carson, California. Inside this office building is this crazy printer called an SLM 500. They actually have a couple of them. One set up for aluminum, like what we used, and another one set up for Inconel alloys, high temperature nickel that they use for exhaust manifold collectors, headers, and other automotive parts and aerospace stuff as well. We already had our intake manifold CAD designed, so all the computer-aided design was done, and we gave that solid model over to the Mnemotechnic guys. They took our CAD model and then programmed the support and then the print strategy for the machine. The way the machine works is it uses really small powder aluminum. So the manifold is going to be made out of this powder. And the way it works is it lays down a 2/1000th of an inch layer of this aluminum powder. That's 0.002. Then it laser welds the first layer of powder to the aluminum plate. That's how they get the material to stick initially. Then the machine comes back and lays down another 2/1000th thick layer of material. So that's half the thickness of a human hair. Then the laser turns on again and welds it in all of the locations where the intake manifold is going to exist. And it does it layer by layer, so cross-section by cross-section. So it keeps putting down a layer of the powder, then laser welding it until you have an entire part. Just the plenum for the intake, the larger round piece for the intake manifold, was 6,991 layers, and the print time took 51 hours. Yeah, over 2 days of printing to get the one piece. Once the print is done, it's actually submersed in all of the powder. So then you have to get the part out of the powder. So you transfer the big box with the part and all of the powder in it over to the unpacking station. You don't want to breathe that powder because it's so small, it's not good for you. So typically they'll wear respirators. They do it in this unpacking station with gloves and everything and a vacuum until you have just the part left, and then they recycle the leftover powder for future parts. So after it prints each layer, the platform goes down that 2/1000th of an inch until the whole box is filled with your part and the powder. In the unpacking station, it goes the other way. The plate will come up and then start exposing the part, and you can see all the powder falling off of it. And then after a few hours of dusting the whole part off and vacuuming everything up, then you've got your part left, and it's safe to handle, but it's not ready to be used yet. Because it's actually welded with all of the support, that's what you see are those, like what looks like cascades of aluminum coming down. The parts actually have to be cut off of the plate because they're welded on right now. But once it's cut off, then it's actually relatively straightforward to clean it up and get it ready to be welded together. The support breaks off relatively easy with just some pliers and then goes and gets recycled. Because the intake manifold is so large and the envelope of the printer is only so big, we actually had to print it in 4 different pieces, and we're going to eventually weld them all together. But before we welded it together, we wanted to make sure all of the surfaces were totally smooth. That way they have a good seal on the engine for the intake manifold. So we brought it over to the shop and fly cut the aluminum so we had a nice smooth surface. Once we had it machined, we brought it back over to Mimo Technic where we bolted it to an aluminum plate, and that aluminum plate allowed Chris to weld it without it warping. Once the whole intake manifold was welded together, we had a couple more features that had to be drilled, and because these are precision holes that need to have a specific surface finish for O-rings for the fuel injectors, we again did that on our mill at the shop. We actually have a special drill bit that has the profile of the fuel injectors that we're going to use all in one drill operation. So even though there's a couple of steps in it, this drill bit has all of those features built in, and it's much quicker. You can just drill 6 holes and the injectors are ready to install. Because it's such an awkward piece, it would have been hard and taken a lot of time to fixture it to be machined. So what we did is we 3D printed a drill guide, and we put these steel inserts into the 3D printed part. That way when we drilled the holes before we tapped it, they would be straight. Because it's really hard sometimes to drill holes straight. And then we also have this tap guide. That way the bolt can bolt in straight. We then put our Injector Dynamics 2000cc injectors into the fuel rail and bolted it all together. The factory engine in this car only has direct injection, which is a really good system, but for the horsepower we planned to make, we needed to run 6 additional injectors, and that's one of the reasons why we built this intake manifold. And the reason we 3D printed it was because we needed it so quickly. The 3D printing was something definitely expensive, but well worth it because of the time savings. And there you have it. All done, ready to get bolted on the engine. This intake manifold is part of a bigger project where we're trying to take this 2020 Super engine and make 1,000 horsepower with it. We've got a few other videos where we do a full teardown and then we show all of the parts that we're changing in it and also the full assembly of the engine. I'll link to those videos in the description down below. If you enjoyed the video, please hit the like button. If you want to see more, please consider subscribing. See you in the next video. Thank you.